So for 5-5, you guys are going to be solving exponential equations. You actually have been doing this already, but with the guess and check method. So, for example, remember I gave you a problem like 2 to the x equals 8. And the way that we did this so far is that 2 to the what power gives you 8? 3, which is something you already know, so you get x equals 3. I'm actually going to show you how to solve it now using algebra as well as using graphing, so 2 different methods to solve, and so then you're going to be able to do a little bit more complicated problems, okay? So we're going to relabel some things in an exponential function, and I know I've already talked to you guys about this before. A times b to the power of x, that's an exponential, right? Okay, b, so the number that's being raised to the exponent, that is called your base. Okay, so it's the base of the exponent. X, you should know, is the what? The exponent, okay? So for this lesson, we are going to use 2 different methods to solve. And I know that when we were looking at systems of equations and solving equations, I used this term, but some of you were still confused about what it meant. Solving something algebraically means that you are solving it using numbers and operations only, no graphing. That's all algebraically means, so no graphing. So solving something algebraically, the first thing we want to do is rewrite the equation so that each side has the same base. I'm going to do this with you. So let's relook at the 2 to the x equals 8 really quick. Okay, so let's work backwards. Instead of using guess and check to solve for x, let's see, can we write the number 8 so that it's a power of 2? 8 is 2 to the what power? 2 to the third. So your first step when you're solving algebraically is going to take your number, the one that does not have an exponent, and you want to write it so that it has an exponent and the bases are the same. Because let's think about logically what this means. If I say 2 to the power of x is equal to 2 to the power of 3, my bases are the same, so what else has to be the same? The exponent. So if we can rewrite both exponents so they have the same base, you can drop the bases and set the exponents equal to each other, and you end up with the same answer as when we use guess and check. This actually is a simpler method when we actually get to more difficult problems. So when we were using guess and check, I was just starting you with simple problems. So the problems will get more complicated. So your first step is to rewrite the equation so each side has the same base, and then this is really wordy, but basically it means set the exponents equal to each other. Okay? So after you rewrite the bases so they are the same, then you set the exponents equal and solve. Okay? I also did not like this word graphical. I like graphically, so I added an ly to the end. But to solve something graphically, you graph each side of the equation, and then the solution is the x-coordinate of the point of intersection. And I'm going to put a box around x-coordinate. So when I'm graphing or solving by graphing, I only want the x-coordinate. I don't want the y-coordinate. Okay. So then we're going to read through the example below, although they did all the work for us, and then we're going to do some example problems together. So right below. What is the solution to the exponential equation 3 to the power of x minus 2 equals 27? So the first method we're going to use is solving algebraically. So they have the problem rewritten down here. Now 27 is 3 to the what power, guys? 3 to the third. So we rewrite it as 3 to the x minus 2 equals 3 to the third power. And now that my bases are the same, you can drop them. And I like to cross them out to show that we're dropping them. And you set the exponents equal to each other. So x minus 2 equals 3. And how would you solve this? Add 2 to both sides. So you get x equals 5. Okay, simple? Okay. Second method is to solve by graphing. So solve by graphing, you need to graph each side of the equation. So we actually have two equations we are going to graph. Y equals 3 to the x minus 2, and y equals 27. So you take both sides of the equation and set them each equal to y, and we'll graph them separately. Okay? How do we graph y equals 3 to the x minus 2? What do we do to graph exponentials? We find the points using a table. Okay? So x and then y equals 3 to the x minus 2. I know they graphed it for us, but I want you guys to actually see the work so you have an example. What are the 5 x's I always plug in? Negative 2, negative 1, 0, 1 and 2. Good. Okay, so we're actually going to find all of these. If I plug in negative 2, that gives me 3 to the negative 2 minus 2, which is 3 to the negative 4, which is 1 over 3 to the 4th, so that's 1 over 81. So that's like really close to the axis, huh? Okay. Negative 1, 3 to the negative 1 minus 2 is 3 to the negative 3, so that's 1 over 3 to the 3rd, so that's 1 over 27. Okay, 0 is going to be a little bit easier. That's 3 to the 0 minus 2, 3 to the negative 2, so that's 1 over 3 squared, which is 1 over 9. Three to the first is 3 to the negative 1, so that's 1 over 3. And then we plug in 2, so that's 3 to the 2 minus 2, so 3 to the 0, which is 1. So they took all of these points and they graphed them right here. And that's how we got this graph. Okay? There's the table. How do we graph y equals 27? It's just a horizontal line through 27. So in this graph, the y is counting by 3 so they can get all the way to 27. So that's how they got the exponential one, is by using the table. Obviously, they graphed more points than what we did. The kinds of problems you guys are going to have will not go that far. And then 27 is just a horizontal line through 27. So they cross at this point. Now, I knew that y was going to be 27 because I graphed it. So I only care about the x value, which is 5. So we get the solution x equals 5. Does it make sense that we got the same answer for both? Yeah, because we did the same problem, just two different methods. Okay? I do have a quick question for you guys. What if you end up graphing something? So let's say I'm graphing an exponential, and it goes like this. And then let's say I am setting it equal to a linear. So then it crosses here. So it's not just a horizontal line, it's actually a linear function. How many solutions will that one have? 2. And where does it look like they would be? Negative 2 and 1. Okay? So sometimes, depending on what two types of functions you are graphing, you might have more than just one answer. Okay? And that's it. So let's look at a couple examples on the back. Really, I'm just going to do one of the fraction ones with you guys, and then I'm going to have you work on some of these on your own. So I'm going to do number 2 with you. So we're trying to get these to be the same base. How can I write 125 as a base of 5? 5 to the what? Well, 125 is 5 to the third, but that's in the denominator and we need it in the numerator, so when I move it up, what happens? It's negative. So this is 5 to the x equals 5 to the negative third. Now can I drop the bases? Yeah, so you end up with x equals negative 3. Okay. In some of the other ones, there might be a little bit more work involved. Okay, so I want you guys to do the rest of the problems, and then we'll check the answers.